CSEC AdMath 2023 June exam. Let's jump right into it. Question 1. So we have an exponential equation to solve. So we can rewrite the power here. So 3 to the 2x times 3 minus 5 times 3 to the x minus 2. So times 3, since it's 3 to the 1, right? So I'm going to have rewriting the powers there. So we can let y be equal to 3 to the power of x, which means this will be y squared times 3, or 3y squared, minus 5y minus 2 equal to 0. And of course we can factorize, we can solve by factorizing. So let's use the AC method. AC, that's 3 times minus 2, that's minus 6. So to think of two numbers that would add to give the middle term minus 5 and multiply to give minus 6, that seems to be negative 6 and positive 1. So this is 3y squared. Rewrite minus 5y as minus 6y plus 1y minus 2 equal to 0. And then we factor by groups. So for the first pair, common factor there is 3y. And we're left with y minus 2 in the bracket. Factor out 1 in the second pair. Same factor in the bracket there, y minus 2. So this means that y minus 2 as a common factor, and we're left with 3y plus 1 equal to 0. And to solve by factorization, we can equate both brackets to 0. So let me just create some space here. We can equate both brackets to 0. Right, so we'll end up with y minus 2 equal to 0, or 3y plus 1 is equal to 0. Solve this equation. Y equal to 2, y equal to 2. And the other, bring over the 1, divide both sides by 3, y equal to negative a third. So we know that y is equal to 3 to the power of x, so therefore 3 to the power of x is equal to y, and the value of y is 2, so equal to 2. We can take natural logs of both sides, so ln 3 to the power of x equal ln 2, which means that's x ln 3 equal ln 2. To solve for x, we can divide both sides by log 3, which means that x will be equal to log 2 divided by log 3. The other value for y, notice if you have, if you let if 3 to the power of x be equal to negative 1/3, if you log both sides, you can't have a log of a negative number. So this would not yield a solution. So the solution there is log 2 divided by log 3. We're asked to put our answer correct to 3 decimal places. So that would be 0.631. Next. So part B, given that 3x plus 2 is a factor of the function here, find the value of b. So we can let f of x equal to the function we are given here, that's 3x cubed plus bx squared minus 3x minus 2. And we're told that 3x plus 2 is a factor. So if 3x plus 2 is a factor, 3x plus 2 can let 3x plus the factor be equal to 0. And if I bring over the 2, you have 3x equal to minus 2. Divide both sides by 3. X equal to negative 2/3. So negative 2/3 is a solution. Alright, so we can, if we find f of negative 2/3, then that should be equal to 0, being that 3x plus 2 is a factor. So let's find f of negative 2/3, and we can do that by replacing the x with negative 2/3. So 3 times x cubed becomes 3 times negative 2/3 raised to the power of 3 plus b negative 2/3 raised to the power of 2 minus 3 times minus 2/3 minus 2. So replace all x terms with negative 2/3, and that should be equal to 0. Alright, let's calculate. So this is 3 times negative 2/3 raised to the power of 3. So negative 2 to the power of 3, that's minus 8. And 3 to the power of 3, that's actually 27. Plus 2 squared, well, negative 2 squared, that's 4. 3 squared, that's 9, so that's 4 over 9, that's b, or 4 over 9 times b. The next term, negative 3 times negative 2/3, so it's negative 3 times, well, 3 cancels 3 here, so negative times negative, that's positive 2, and there's a minus 2 here, right? So equal to 0, so this will be 2 minus 2. So we're left with, so 3 times, so 3 into itself 1, and 3 into 27, 9. So we're actually left with negative 8 over 9 plus 4b over 9 equal to 0. So this, since both of them have a common denominator of 9, we can put the numerators together. So we have minus 8 plus 4b over 9 equal to 0. You can just make this a fraction, cross multiply. So we end up with negative 8 plus 4b is equal to 9 times 0, that's 0. 1 times that, negative 8 plus 4b. Bring over the 8, the negative 8, we have 4b equal to 8. Divide both sides by 4, we get b equal to 2. So next we're asked to hence factorize completely the expression. Now we know that b is equal to 2 from above, and we know that 3x plus 2 is a factor. So because 3x plus 2 is a factor, then to get the other factor, we can just simply divide the expression by 3x plus 2, right? So let's do that. So we're going to do a long division. So we have 3x plus 2 divided into 3x cubed. We know the value of b is 2. So 2x squared minus 3x minus 2. So long division, so 3x divided into 3x cubed. That will give us x squared. And then we use x squared and multiply to the factor. So x squared times 3x, that's 3x cubed. X squared times 2, that's 2x squared. And of course we can subtract term above minus term below. So 3x cubed minus itself, that's 0. 2x squared minus itself, that's also 0. Alright, so we can just bring forward the other two terms here. That's minus 3x minus 2. And then of course we can divide 3x into minus 3x, that's actually minus 1. And we take the minus 1, multiply it to the factor. So minus 1 times 3x, that's minus 3x. Minus 1 times positive 2, that's minus 2. And of course we subtract, so it's minus 3 minus 3x, that's minus 3 plus 3x, which is 0. Likewise minus 2 minus minus 2, that's minus 2 plus 2, which is also 0. So no remainder as we expect, since 3x plus 2 is a factor, right? So hence the other factor is x squared minus 1. So the function, so this factor is a 3x cubed plus 2x squared minus 3x minus 2. When factorized, well, one factor is 3x plus 2, and the other factor is x squared minus 1. And if we are solving by factorization, then we can just equate both factors to 0. Well, we're not solving, right? We're just told to factorize completely. So let's factorize. You should recognize that x squared minus 1 can be seen as x squared minus 1 squared, difference of squares. So factorize as x minus 1, x plus 1. So we were not asked to solve. We were simply asked to factorize the expression. Alright, let's move on. Determine the values of p for which the function has two real distinct roots, given your answer in the simplest form now. So a quadratic, so is a quadratic function, a quadratic of real and distinct roots when b squared is actually bigger than 4ac. So b is a coefficient of the x, so b is 3. So 3 squared must be greater than or equal to 4 times a times c. So this is the b term. A is a coefficient of the x squared. C is a constant there, 2p. So 4, a is p, and c is actually 2p. So 9 must be greater than or equal to 4 times 2, 8, so 8p squared. So we can divide both sides by 8. So 9 upon 8 is greater than p squared, which is same as saying p squared is less than 9 over 8, which means that p, so p, if we take the square root of both sides, p is less than square root of 9, square root of 9 over 8. Alright, or p is greater than the minus square root of 9 over 8. In other words, p should be between, since it's less than, p should be between the positive square root and p should be greater than the negative square root. Let's move on. Given the function f of x equal to 3x squared minus 9x plus 1, express f of x in this form here, complete in the square form. Alright, let's do that. So f of x, so the first thing I'm going to do is factor out the coefficient of the x squared, which is 3. So I'll factor out the 3, and so x squared minus divided by 3, that's 3x plus a third, and then I can complete the square, so this is 3. So to form my square, so in my bracket x minus half of the b term, so that's 3 over 2, minus the square of said term here, that's 9 over 4, plus the constant outside, that's 1/3. And then now I can redistribute the 3. So this is 3 times the square bracket, so x minus 3 over 2 square. 3 times 9 over 4, well, that's negative 27 over 4. And 3 times 1/3, that's 1. So I'll end up with 3x minus 3 over 2 square minus 27 over 4 plus 1. Now 1 let me rewrite 1 as 4 over 4. So it's same denominator, 4, so I can just add negative 27. And 4, that's negative 23. So therefore, the coordinates of a minimum point would be the x coordinate, the x value, that makes a bracket 0, that would be 3 over 2. And the y coordinate is whatever is here, that's negative 23 upon 4. Part B, the quadratic equation 3x squared minus 6x minus 2 has roots alpha and beta. Find the value of 1 over alpha plus 1 over beta. So we know for the quadratic, the sum of the roots is equal to negative b over a, and the product of the roots should be equal to c over a. So a, the x squared coefficient, b, which is 3, b, the x coefficient, which is minus 6, and the constant there is minus 2. So the sum, if the roots are alpha and beta, then the sum will be alpha plus beta, which will be negative b. Now b is negative 6, so negative b would be positive 6. Negative b would be actually positive 6, a would be positive 3, so alpha plus beta, the sum would be actually be 2. The product, which is alpha times beta, is c over a. Now c is minus 2 and a is positive 3. So now we are actually use these and deduce the value of 1 over alpha plus 1 over beta. So let's calculate. So 1 over alpha plus 1 over beta. We can make a common denominator. Alright, the common denominator will of course be alpha beta. And then the numerator, that's cross multiply there, would be alpha plus beta. So this would be alpha plus beta divided by alpha beta. Now alpha plus beta is positive 2 divided by alpha beta, which is negative 2/3, which is equivalent to positive 2, we can just times and reciprocate, minus 3 over 2, 2 into itself, leave us with negative 3. So our solution is minus 3. Next, John's grandparents started a university fund for him at a bank with $4,000. The bank offered 2 options for interest. Option 1, $240 per annum. Option 2, 5% of the current balance per annum. Determine the sum of money in the university fund at the beginning of the 9th year. So at the beginning of the 9th year, I guess is what we can see the same as the end of the 8th year. So what we're going to want to calculate is the sum of money in the fund at the end of the 8 years. Alright, so let's deal with option 1. So we also determine sum of money for both options. So let's deal with option 1 first and foremost. So option 1, of course, option 1, the sum of money. So of course, it started with 4,000, and each year thereafter, interest of $240 per annum was paid, and at the beginning of the 9th year, so none would be paid in the 9th year since it's just at the start. So at the end of the 8th year, so that would be 8 years. So 8 year, and each year the interest will be $240. So the sum will be 4,000 plus you add 240 8 times, right? Because interest is not paid until the end of the year. So we won't count the 9th year. Alright, so 4,000 plus 8 times 240, that's $5,920. option 2 and option 1 seems to be an arithmetic progression. Option 2, I will assume it's a option 2 situation. So the interest 5% of the current balance per annum. So I guess we can assume it's a geometric progression. Alright. It's a compound interest situation. So the sum in the fund, what's the formula for the compound interest? So it's principal 1 plus r to the power of n. So the principal was $4,000. So r is 5%, alright? So r, 5%, that's 5 over 100, so r is 0.05. So the bracket will be 1 plus 0.05, that's 1.05. And we're talking about the end of the 8 year, so n will be 8. I'll do this calculation. We get the nearest 5,910 approximately. Question 3. The equation of a circle is, and we are given the equation there, determine the coordinates of the center of the circle. So the first thing we want to do is rewrite this problem, write the circle equation in the standard form. Let's group the x terms. So we have x squared, and we have minus 8x, and we have y squared, minus 18y, and the positive 9, I'm going to group the 93 on the other side, so that will be negative 93. Alright, so let's complete the square now for the x term. So x minus half of the 8 there, that's 4, minus, and you square the constant here, 16, so minus 16, plus y, half of the 18 there, that's 9, 9 squared is 81, so we subtract that 81 there, equal minus 93, so we bring over the constants, so x minus 4 square, y minus 9 square, equal to minus 93. And let's bring over the negative 16, which is plus 16, and the negative 81, that's plus 81. So we end up with x minus 4 square plus y minus 9 square, and negative 93 plus 16 plus 81, that gives us 4. So the center of the circle would be with the values that makes the bracket 0. First for the x, it's 4, and for the y, it's 9, and the radius, so on the right hand side here is r squared, so r squared equal to 4, so the radius r equal to 2, well, 2 units. Find the equation of a normal to the circle at the point 2, 8. So let me do a sketch. Let's do a sketch of the circle here. And the center was 4, 9, right? Center was 4, 9. Alright, so let me just, that would be the radius. So tangent would look something like that. Tangent 1, so a tangent would look like that. The normal, so this would be the tangent. Touches the circle only once. The normal would come like that, and of course the angle between the tangent and the normal should be a right angle, 90 degrees. So this is a normal. So this is the equation of the line that we want to form. We're told the point here is 2, 8. So this is the line that we want to find. So to find the equation for this line, we need the gradient. Let's find the gradient of the normal. So gradient of normal. So the gradient, and so the normal will be the same line as the radius. So we can call this x1, y1, and we can call this x2, y2, the 2, 8, right? So the equation, y1 minus y2, or y2 minus y1, 8 minus 9, that's negative 1, and x2 minus x1, 2 minus 4, that's negative 2, so that's a half, right? And then now we can find c, so we know y equal mx plus c. Let's substitute one of the points. Let's substitute 2, 8, since we know it passes through 2, 8. So we're going to replace a y with 8. M, we know m is a half. X is 2 plus c. Alright, so 8, half of 2, that's 1. To solve for c, just bring over the 1 here, so it's 8 minus 1. Equal to c, so the value of c is 7. So therefore, the equation of a normal is y equal mx plus c, mx, but we know m is half, so half x plus c, and we know the value of c is 7. Let's continue. Part B, the position vectors of 2 points A and B relative to an origin O, such that OA is 3i minus 1j, OB is 5i minus 4j. Determine the unit vector AB. Alright, determine the unit vector AB. So AB, so let me do a little sketch here. So you have O, and you have A, and you have B, alright? So we can look at it several ways. We know the vector AB. We know the vector AB is, we can say the vector AB is AO plus OB, or we can say it's the coordinate of B minus the coordinate of A. Just reverse subtract. The coordinate of B is same as OB, which is 5i minus 4j minus, and the coordinate of A is 3i minus j. So this is 5i minus 4j, distribute this, so we have minus 3i, distribute, multiply by negative 1, so that's positive j when expanded. So this is the group the i's, that's 5i, take away 3i, that's 2i, and negative 4j plus 1j, that's negative 3j. Now to get the unit vector AB, we also need the modulus of AB. Alright, so the modulus of AB is the square root of x squared plus y squared. So the square root of 2 squared, so 2 squared is 4, plus the square root of the y, that's negative 3. Square, well, negative 3 times itself, that's positive 9, right? So it's the square root of 13, that's the modulus of the vector. So therefore, the unit vector AB, so therefore, unit vector AB is equal to 1 over the modulus, so 1 over root 13 times the vector itself, and the vector itself was 2i minus 3j. Part 2, calculate the acute angle AOB. So AOB, notice AOB is where the vector OB and the vector OA intersect. So let's say angle 1, let's call it theta. We have a formula for that. So cos theta would be the dot product of the two vectors, in this case OA and OB, over the modulus of OA times the modulus of OB. So we can just put it in column form already. So the modulus of OA, let's put OA in column form. So OA is 3, -1, so just 3i minus 1j, so 3, -1, that product with OB. OB is 5, -4, let's put it in column form, 5, -4. And the modulus of OA, square root of 3 square plus 1 square. Well, -1 square, 1 square, the same thing, you get 1, right? Times 5 square, which is 25, plus 4 square, or -4 square, same as 4 square. Alright? So what we end up with is cos theta is equal to, so the dot product, so 3 times 5, that's 15, plus -1 times -4, that's +4, over, so the modulus here, this is 3 square, 9, 1 square, 1, so it's 9 plus 1, that's root 10. And this is 5 square, 25, plus 16, so 25 plus 16, that's 41, that's the square root of 41, which means that cos theta would be equal to 19 over the square root of 410. Therefore, theta would be cos inverse 19 over the square root of 410. Okay, I have to enter that in the calculator. So theta, and they want the answer to 1 decimal place. So theta, 20.2 degrees. Next, we're asked to solve the equation 2 sine squared theta equal 3 cos theta. Okay, so we know that from the Pythagorean identity that sine squared theta plus cos squared theta is equal to 1. So we want to make this equation one term, so we can rewrite sine squared. Notice if your group is cos squared on the right hand side, sine squared would be 1 minus cos squared theta. So we can substitute that into this, so rewrite this problem by rewriting this sine square as 1 minus cos square. So 2 sine square will becomes 2 times 1 minus cos square theta equal to 3 cos theta. Distribute the 2, so we end up with 2 minus 2 cos square theta equal 3 cos theta. And of course we can group everything on one side. Since it's a quadratic, I personally like to have my square term as positive, so I bring over the -2 square. I end up with +2 square, 2 cos square. And then I'll have +3 cos theta. And the 2 also group on the right hand side is positive, so it's now -2. And then to factorize, I can just rewrite +3. So if you think of it, AC is 2 times -2, so AC is -4. So we need two numbers that multiply to give -4, but at the same time add to give +3. And that's -1 and +4. These numbers would add to give +3 and multiply to give -4. So we can rewrite the middle term. So 2 cos square theta. And then the 3 cos theta I can write as minus 1 cos theta plus 4 cos theta. Or I could have said 4 cos theta minus cos theta, as long as I end up with 3 cos theta in the middle, minus 2. And of course we can factor by groups now. So the first pair, the common factor there is cos theta, so cos theta in the bracket I'll have 2 cos theta minus 1. The second pair, common factor there is 2, and in the bracket I'll have 2 cos theta minus 1. Notice we have a common bracket, which is what we expect. That common bracket is 2 cos theta minus 1. On the outside, we have cos theta plus 2. And then to solve by factoring, we equate both factors to 0. So we can equate, so therefore 2 cos theta minus 1 is equal to 0, or cos theta plus 2 is equal to 0. Let me just continue up here. Alright, so continuing up here. So if 2 cos theta minus 1 equal to 0, I can just bring over the 1. So that would be, which would mean that 2 cos theta is equal to 1. Divide both sides by 2. Cos theta is equal to half. And theta is cos inverse half, or cos inverse 0.5, and cos inverse half. That's 60 degrees, and they only want the angle between 0 and 180. The other angle will be 300, alright, but we have a limit here of 180. The other factor, cos theta plus 2 equal to 0. If we're solving for this, this is one solution. So cos theta is equal to, bring over the 2, that's negative 2. So this is obviously math error, since cos theta, the smallest value for cos theta is negative 1. Right, so this would give, if you try to solve theta equal cos inverse 2, you'll get math error, you won't get a solution. Cos inverse minus 2, sorry. Alright, so the only solution there, 60 degrees. Next is an identity, a trig identity we need to prove. So let's begin from a side that has more terms, which is the left hand side. So the left hand side, of course, the first thing we should seek to do is to have one common denominator. So we can just take the product. So 1 minus sine x times 1 plus sine x. And then to get the numerator, we can just cross multiply there. So it's 1 plus sine x, cross multiply, minus 1 times 1 minus sine x. Alright, so we get a common denominator by taking the product of both denominators. Alright, let's expand. Now notice, let's do the denominator first. So 1 times 1, that's 1. 1 times sine x, that's 1 sine x. And then minus sine x times 1, that's minus sine x. And then minus sine x times sine x, that's minus sine square x. In the numerator, just 1 plus sine x. Distribute the negative 1, that's minus 1 plus sine x. Remember, negative times negative is positive, right? In the denominator, these two megaterms cancel. So what we have is 1 minus sine square. And in the numerator, this positive 1 cancel with negative 1. So what we have is just 2 sine x. So this becomes 2 sine x over, no, 1 minus sine square. We did it earlier. Remember that sine square plus cos square is 1. So 1 minus sine square is equivalent to cos square. So we need to keep an eye on what we're trying to prove. So 2 tan x over cos x. So let's break up the cos square into cos times cos. So this is 2 sine x. I'm going to rewrite cos square now as cos times cos. So this is cos x Let me write 2 sine x. Cos times cos, so cos x times itself, cos x. Now we know that sine x over cos x is tan. Alright, so this is equal to 2 times sine x, so that is 2 times tan x. So sine over cos, that's 1. So this is 2 tan x. And of course, we'll still have a cos x in the denominator. And this is exactly what's on the right hand side. 2 tan x over cos x. Alright, so this proof. So we have just completed the proof.